Okay, in this video, we're going to go over how to multiply matrices together. And I have a list of 3 matrices in the top here, and we have 4 questions that we're going to go through for this problem. So the first thing we need to do when we want to multiply matrices together is we need to recognize what are the dimensions of the matrices we have. And to work out the dimensions of a matrices, it is always rows, number of rows, times by the number of columns that you have. So let's look at matrix number A. We have 2 rows and 2 columns. So in this case, we would have a 2 row by 2 column matrix, a 2 by 2 matrix. Now let's have a look at matrix B. Matrix B, we have 2 rows, but we only have 1 column. So it's a 2 row by 1 column or a 2 by 1 matrix. And lastly, we have another 2 by 2 matrix. So this is how we work out the dimensions of our matrices, and it's very important when we want to multiply matrices together. And the reason for this is the following. I don't know why my thing has glitched out. The reason we need the dimensions of our matrices is, let's suppose we start off with question number 1. Question number 1 asks us to multiply the matrices of A and B together. So 2, -1, -1, 3, times by the matrice 1, 3. So the first matrix has the dimensions of a 2 by 2, and the second matrix has a dimension of 2 by 1. 2 matrices are only multipliable with each other if the inside numbers are the same. So that means that the number of columns in the first matrix must be equal to the number of rows in the second matrix. Okay, so the number here and here must be the same. If they are different, okay, if they are not the same, that would indicate that you cannot multiply those 2 matrices together. But because we have these 2 matrices together are multipliable, let's work out how to multiply them together. So after we have this step, let's first work out what is the dimension of our final matrix. The final matrix will have the dimensions of the outer 2 numbers here. So the inside 2 numbers tell you whether or not the 2 matrices are multipliable to each other. I'll write this down just so it's easier for the viewers. So if these 2 numbers are the same, okay, these 2 numbers are equal, okay, that means they are multipliable. Matrix A and B are multipliable with each other. But then if you have a look at the outside 2 numbers, okay, the outside 2 numbers tells you whether or not the 2 matrices have a dimension. So it tells you what dimension of the matrix is. So we already know that the dimension of the final matrix will automatically be a 2 by 1 matrix. So it'll be looking like this, AB. Okay, so this is the steps we need to take before we even multiply 2 matrices together. Okay, enough chatter. How do we actually multiply 2 matrices together? Here is how it goes. We can recognize that we have 2 entries, A and B. In the top entry, that would be classified as the first row of the matrix and also the first column of the matrix. So here's what we do. We look at the first row of the first matrix and the first column of the second matrix. And that is correspondent to the value in the final matrix. It is the first column, first row. So what we end up doing is we multiply each term with the subsequent term in the next matrix, and then we add them together. If that sounded like a whole bunch of yap, here's what that actually means. We do 2 times 1, so these are the first terms in each of the circles or ovals I have over here. So 2 is the first term in the first matrix, in the first row, and 1 is the first value in the second matrix, but of the first column, or the only column. So we do 2 times 1, so our final matrix will be a 2 times 1, okay, as the first number. And then we add the second terms multiplied with each other. So -1 times by 3 will give us -3. So we can do plus -1 times 3. And if we work this out, we won't do it just yet, but that is the first value of the first row, first column of our final matrix. So now let's work out, how do we work out the value of B? How do we work out the value of B here? Well, if we want to work out the value of B, we would need to look at the second row but it's in the first column. In this case, I'm saying first column as if there are more columns, but it is the only column in this matrix. So first row, first column. Second row, first column. So in our first matrix, we look at the second row, first column. Okay, so no longer going to highlight that one there. We're going to highlight the second row. So now here's what we do. We do the exact same steps. -1 times by 1 is our first step. -1 times 1. And we add that with 3 times 3. 3 times 3. And in this case, our final matrix will simply be whatever we evaluate the two rows to be. So 2 times 1 is 2, plus -1 times 3 is -3. So 2 minus 3 is -1. And then -1 times 1 is -1, and 3 times 3 is 9. -1 plus 9 is equal to 8. And this is here our final matrix for what A times B is. Okay, so have a screenshot of this or write this down. You can also pause the video, but I'm going to move on to how to work out A times C. So let's erase all of this and work out the matrix of A times C. So in this case, the matrix A times C is really the matrix of 2, -1, -1, 3 times by the matrix -2, 1, 1, 4. So before we even do anything, are these two matrices multipliable with each other? Well, the first matrix is a 2 by 2, and the second matrix is also a 2 by 2. So in order for two matrices to be multipliable, the columns of the first matrix must equal to the rows of the second matrix. So the inside two numbers must be equal to each other. So if they're equal to each other, that means they're multipliable. So they're multipliable, and the dimensions of the matrices are the outside two numbers of our matrix column row notation. So in this case, the final matrix will have the dimensions of a 2 by 2. So it'll look like this: A, B, C, D. So now let us work out the values of A, B, C, D by multiplying these two matrices together. So the first thing we do is, let's say we want to work out the value of A. If we want to work out the value of A, this value here, we know that A corresponds to the first row of this matrix and the first column of this matrix. You can clearly see that this is the first column and this is the first row, and the intersection between the two gives us the value of A. So now what we have to do is we have to use our two matrices here respectively. We need to use the first row of the first matrix, and we have to use the first column of the second matrix. We see we have two values or two entries in each of these green ovals. So let us now work out what is the value of A. What is the value of our matrix in that entry? So the value of A will simply be 2 times -2. So 2 times -2 plus -1 times 1. Okay, that is the value in that matrix there. And we can easily work that out right now. So 2 times -2 is the same as -4. Plus -1 times 1 is -1. -4 minus 1 is the same as -5. Now we can work out the value of B. Okay, the value of B would be the following. We need to recognize that B is the second column, so it's column 2, but it's still row 1. Okay, so it's still row 1, column 2. So I'm going to do the highlighting method that I just did before. So row 1 in the first matrix, but now column 2 in the second matrix. So now what we have is, to work out the value of B, we can do 2 times 1 plus -1 times 4. And 2 times 1 is just 2, and then -1 times 4 is just -4, and 2 minus 4 is simply -2. So that is the value of B. Let's speed up the process. We can now do in this column, in this third entry over here, we can do the second row times by the first column, and that gives us the value of C. So -1 times -2 is 2, plus 3 times 1 is 3, so this gives us 5. Then in the last column, in this last entry, D, we can use the second row as well as the second column. So -1 times by 1 is -1, plus 3 times 4 is 12. So this gives us 11. And this is the value of the matrix when we multiply these two together. And that's how you work it out. So screenshot this, take a photo, write this down, pause the video, but we are going to move on to the next question. B times C. Okay, so first thing we do is we need to recognize, are these two matrices multipliable or not? So 1, 3, multiplied with -2, 1, 1, 4. So the first matrix is a 2 by 1 matrix, and the second one is a 2 by 2 matrix. Can you multiply these two matrices together? For those of you that said yes, I want you to rewind the video and see what I said before about whether two matrices are multipliable or not. But for this one here, they are not multipliable. I repeat, they are not multipliable. Why is that? The reason they are not multipliable is because if you look at the columns of the first matrix and the rows of the second matrix, they do not equal each other. They are not the same. And in order for them to be multipliable, you need to make them the same. You need to have the same rows in the second column and same columns in the first matrix. So there's just no way we can multiply these two matrices together. So I'm just going to skip this question. Okay, and then the last question we have is C times A. C times A is the same as -2, 1, 1, 4 times by -2, A is 2, -1, -1, 3. So now let us work out what is the value or the size of our final matrix and whether or not these two matrices are multipliable. So the first one is a 2 by 2, second one is a 2 by 2. Can you multiply these two matrices together? Yes, you can. And the reason is the number of columns in the second matrix is the same as the number of rows in the second matrix. Sorry, the number of columns in the first matrix is the same as the number of rows in the second matrix. So the inside two numbers are the same. Okay, that's all I'm trying to get at here. And we have the inside two numbers are the same, and the outside two numbers correspond to what the dimensions of the matrix are. So it's a 2 by 2 matrix. So that's why we have a 2 by 2 matrix drawn here, where it's A, B, C, and D. Okay, so let us now quickly work out what is our final matrix. So our final matrix, let's work out the value of A first. So this is the first row and the first column. First row, first column. -2 times 2 is -4. And then 1 times -1 is -1. So add them together, you get -5. Now we have the value of B. First row, second column. First row, second column. -2 times -1 is simply 2, plus, and then 1 times 3 is 3, so 2 plus 3 is simply 5. Now the value of C. C is the second row, but the first column. Second row, first column. 1 times 2 is 2, plus 4 times -1 is -4. Add them together, you get -2. And lastly, the value of D. This is the second row and the second column. So second row, second column. 1 times -1 is -1. And then 4 times 3 is 12. So now we get 11 here. And that is how you multiply these two matrices together. So we recognized from these three matrices here and the 4 questions that followed, we recognized that the first 2 matrices were multipliable with each other. The last matrix was multipliable with each other, but the third question, we did not allow multipliability because the dimensions of the inside two numbers did not correlate with each other. Okay, so we have this next problem here. John takes 5 minutes to drink a milkshake that costs $2.50 and 12 minutes to eat a banana split that costs $3. Find the matrix multiplication of these two here and interpret what the result means. So I'll give you a second to try this question yourself, so pause the video before you have a go. Okay, that's enough time. If you haven't paused it already, too bad. So let us first interpret what this matrices even mean. Okay, so all of a sudden we went from drinking milkshakes and eating banana splits to now a 2 by 2 and a 2 by 1 matrix. What the hell, bro? So let us first work out what do these matrices even mean. So first off, we have a 2 by 2 matrix and a 2 by 1 matrix. We can see that the 5 corresponds to taking 5 minutes to drink a milkshake, which costs $2.50. So we have the first column corresponds to the information that relates to the relates to the milkshake. And the 12 and the $3 corresponds to 12 minutes to eat a $3 banana split. So the first column is to do with the milkshake, the second column is to do with the banana split. And we have the second matrix here, which is 1, 2. And it might be a little bit easier to understand what this second matrix is trying to explain if we actually first just multiply them together. So first of all, can you multiply these two matrices together? Yes, you can, because the number of columns in the first matrix is the same as the number of rows in the second matrix. So what we can actually just do is we can just draw our final matrix, and the dimensions of our final matrix is the outside two numbers. It's a 2 by 1. So we have values A here and B here. Okay, it's a bit of a fat matrix. But here you go. This is our final matrix and what it looks like. So let's work out what our final matrix is. To work out what A is simply the first row and the first column of this entry. So first row times by the first column. So 5 times 1 is 5, plus 12 times 2 is 24. Then we can do 5 plus 24, which is simply 29. Then we can do 2.5 and 3 times by 1 and 2, because we're trying to work out what B is, because this is the second row and the first column. So second row, first column, 2.5 times 1 is 2.5, plus 3 times 2 is simply 6. So if we add them together, we get 2.5 plus 6 is 8.5. So this is our final matrix. Let us now interpret what this means. So if I were to write it nicely, this means the first column in this matrix is referring to everything about the banana. Is it the banana? No, it's the milkshake. So this is to do with the milkshake. Okay, and we know the first column talks about both the time it takes to eat, the time it takes to drink one, and the cost of one milkshake. So the first row tells you the time, and the second column tells you the cost. And just to make it more space, this is milkshake. And the second column talks about the banana split. So you have a banana split, the time it takes to eat the banana split, time it takes to eat, the cost of eating one banana split. And this matrix here is pretty much saying, let's first interpret the first value here. To work out the first value, we had to do the cost, not the cost, we're talking about first row, the time it took to eat a milkshake and a banana split, and we times it by both 1 and 2. So 5 times 1 would imply that John here ate just one milkshake, and it took him 5 minutes to eat that one milkshake. And then to eat a banana split, we did 12 times 2. That's how we got the 29. So 12 times 2 implies he had 2 banana splits. Each of them takes 12 minutes to eat. So that would mean 5 plus the 24 minutes it took to eat a banana split equals 29 minutes in total of eating time. So this really relates to the time it took to eat both a milkshake as well as a banana split. So that's what this 29 refers to. The 8.5, however, is this row times by this column. So we did 2.5 times 1, which refers to the cost of one milkshake times by 1, and 3 times 2, which relates to the cost of one banana split times by 2. So what we can realize here is he had 3 items. He had one milkshake and he had 2 banana splits. And the total cost of the entire meal was $8.5. So this here is the cost to eat both a milkshake and a banana split. So that is how we can interpret this final matrix here. We can put units here as well. This is minutes and this is dollars. But that's what this final 2 by 1 matrix really means. Okay, so we took time and cost here, and this is really just the culmination of banana split and a milkshake. Now let's have a look at this problem here. Okay, we have same problem, part B of the previous question. We have 2 friends that join John. So now we have to find the final matrix multiplication of this, and we have to interpret our results. So before we actually even multiply these matrices, let's interpret our results. So we recognized before, we didn't even have these numbers before. We just had this matrix here, a 1 and a 2. So this corresponded to the final matrix being a 2 by 1 matrix. So it's a 2 by 1 matrix. We knew the top number was the total time he took to eat each product. And the bottom column here was this total cost of eating each item. So this was just for John. So what do you reckon the next two entries, the next two columns here would represent? Well, the next two columns would probably represent both the time as well as the cost of each friend eating a banana split and a banana milkshake. Banana split and a milkshake, sorry. So let us now multiply these two matrices and work out what the final answer is. So the first matrix is a 2 by 2 matrix. Second matrix is a 2 by 3 matrix. Are they multipliable? Yes, because 2 and 2 are the same. The inside numbers are the same. What's the dimensions of the final matrix? Well, it's a 2 by 3 because it's the outside numbers. So we have A, B, C, D, E, and F. The value of A, okay, is first row, first column, first row, first column. We already technically have the values of A and D because we did this multiplication earlier. It was 29 and 8.5. So I'm just going to write 29 and 8.5 here. Now let's work out the value of B. B is the first row, second column. First row, second column. 5 times 2, that is 10. And so 5 times 2 is 10. Plus 12 times 0 is just 0. So our final answer here is just 10. Now let's work out E. E is the second row, second column. Second row, second column. 2.5 times 2 is 5, plus 3 times 0 is 0, which is just 5. Then we can say, work out C and F. Let's work out C first. So to work out the value of C, we need first row, third column. First row, third column. 5 times 0, that's just 0. 12 times 1, that's 12. So now we have 12 here. And to work out F, we do second row, third column, second row, third column. 2.5 times 0 is 0. 3 times 1 is 3. So the answer here is just 3. So let us now interpret our results. This here is talking about John, friend number 1 and friend number 2. And this is the total time as well as the total cost. Okay, so what we're saying here is John took a total of 29 minutes. Friend 1 took a total of 10 minutes to eat his meal. And friend 2 took a total of 12 minutes to eat his meal. Whereas when coming about prices and cost, John spent a total of $8.5 for his meal. Friend number 1 took $5 to eat the entire meal. And friend 2 ate the entire meal for $3.